high-bare IP20C system configurations. This module introduces the system configurations achievable with IP20C. The agenda of this module will cover the following topics: multi-core network needs and benefits, multi-core configurations, such as multi-core 2+0 single or dual polarization, multi-core 2+2 hot standby single polarization, 2 times multi-core 2+0 dual polarization, 1+1 hot standby with space diversity, 2+0 space diversity or 4x4 MIMO, multi-core 2+2 hot standby dual polarization, 2 times multi-core 2+0 single polarization, 1+0 space diversity or 2x2 MIMO, east-west configuration, advanced frequency reuse and advanced space diversity. A standard radio is equipped with one core only, which means that, once the link is in place, the only way to upgrade your link capacity is by installing a new link in parallel. This is not the case for IP20C, because of its multi-core technology. Just by enabling the second core of the same radio, this will immediately double the link capacity. No physical change in installation is required, just the software license and remote enablement of the second core, all of these without any impact on traffic on the first carrier. An IP20C 1+0 link is by definition hardware ready for a 2+0 configuration. The second carrier can be adjacent channel, either same or different polarization, or it can be the same channel in different polarization. Just a dual-core splitter is needed for multi-core 2+0 single polarization configuration, or use an OMT for multi-core 2+0 dual polarization. More discussions on the mediations devices will follow in the coming slides. Another option provided by IP20C is this: by lowering the modulation per each core will increase achievable link distance because of better system gain. Here is the same principle like in previous slides, but the link distance is kept and the antenna size is reduced. So the multi-core technology allows the utilization of much smaller antennas when needed. Using unique 4x4 MIMO with 4 carriers and 2 radios will quadruple link capacity, using the same frequency and 2 polarizations. By using MIMO, you can double the capacity, as compared to an X-PIC link. Or you can double the distance. Going from multi-core 2+0 X-PIC to 4x4 MIMO makes possible to increase the link distance, when each core uses lower modulation. As we discussed, this is due to the fact that going into lower modulation will greatly increase the system's gain. Let's now go, one by one, into IP20C multicore system configurations. Here is a list with all possible configurations, starting with multi-core 2+0 single polarization on the top left, and ending with 1+0 with space diversity on bottom right. Each setup shown here will be analyzed in the coming slides. But before going over each system configuration, let's highlight the available mediation device. Thus we have the OMT mediation device, used whenever transmission is happening on both polarizations. The splitter, used to aggregate the 2 carriers of IP20C over one port. The dual coupler mediation device, used in 2+2 hot standby configurations. The dual splitter mediation device, used to aggregate the 4 carriers of 2 IP20C units over 2 ports. The signal attenuation from each IP20C unit is equal, symmetrical. And finally the dual-core mediation device, used for 1+0 with space diversity, 1+0 advanced frequency reuse, 2+2 MIMO and also east-west system configuration. Let's see in this slide a bit closer the dual-core mediation device, which is equipped with 3 antenna ports, as compared to the rest of the mediation devices which have only 1 or 2 antenna ports. The dual-core mediation devices is designed to offer a simple and compact solution for 2x2 MIMO configuration or 1+0 with space diversity configuration. Let's now analyze closer the system configuration options we have for IP20C and the required mediation device for each solution. In this slide, note, from top to bottom, the 2+0 dual polarization with adjacent channel, called ACAP, which means adjacent channel adjacent polarization. The 2+0 dual polarization with co-channel, called CCDP, which means co-channel dual polarization. And the 2+0 single polarization, called ACCP, which means adjacent channel copolarization. If the same polarization is used for both carriers, a splitter mediation device shall be used. If the two carriers run over different polarization, an OMT mediation device shall be used. This is the 2x2+0 single polarization configuration. A splitter and a dual splitter is needed in this scenario. For customers who already have RFUC splitter and wish to implement the same 2x2+0 single polarization configuration, 2 splitters will be required as shown in this slide. For the same 2x2+0 configuration but this time in dual polarization, an OMT and a dual splitter will be required as shown in this slide. Let's now evaluate the hot standby options we have. First, see the 2+2 hot standby with single polarization configuration. As usually for hot standby configurations, a coupler is used, giving different attenuations on its 2 branches, 1 branch towards each IP20C unit. So for this particular configuration, a dual coupler must be used together with a splitter. For the same 2+2 hot standby configuration but this time using both polarizations and XPIC mechanism, a dual coupler must be used together with an OMT. Remember, the OMT is the device allowing us to operate in both polarizations. If you plan to use the classical 1+1 hot standby but to include also the space diversity mechanism, just a dual coupler must be used, and, of course, a second antenna. Finally, let's check the standard 1+0 with space diversity for which a dual-core mediation device must be used. Note that the same mediation device and setup must be done if using the 2x2 MIMO configuration. Let's now have a look at one of the most complex installations with the IP20C, the 4x4 MIMO configuration. As you will see from the explanations, there are some similarities between the 4x4 MIMO assembly and 2+2 hot standby with space diversity or 2+0 with space diversity. A. For 4x4 MIMO assembly, 4 units are used, 2 at each end. Initially, 2 separate 2+0 XPIC links will be installed, one on top of the other, at a specific distance between the antennas on each end. Once the links are functional and working, the adjustments can be done for converting to a 4x4 MIMO installation. Please pay special attention to the cables used and observe the following. 1. There is a source sharing connection through a coaxial cable done between the 2 external reference TNC connectors of the units on each side of the link. 2. An optical fiber cable with 2 special designed SFPZ are used to connect the 2 ports marked with Ethernet 3 or external on each side of the link. 3. The management Y-splitter electrical cable is used like this. Channel 1 to channel 1 from the 2 units are connected via a switch with straight crimped cables. The Y-splitter cable's channel 2 is connected to the other unit's channel 2 with a cross-crimped cable. 4. Another optical Y-splitter cable or Ethernet with external link aggregation is used to send traffic from the traffic generator unit to the Ethernet port used in each machine. Access of the VLANs inside each machine is done with the help of service points. B. For 2+0 space diversity, only one of the network elements on one side will have radio transmission. The other network element in the site will be connected to a second antenna, but completely muted, only with reception. C. For a 2+2 hot standby with space diversity, remember that in effect, a 2+2 hot standby configuration is a protected 2+0 space diversity configuration. Each IP20C monitors both of its cores. If the active IP20C detects a radio failure in either of its cores, it initiates a switch over to the standby IP20C. The 2+2 space diversity provides equipment protection, as well as signal protection. If one unit goes out of service, the other unit takes over and maintains the link until the failed unit is restored to service and space diversity operation resumes. In each IP20C unit, both radio carriers are connected to a single antenna. 1 gigabit Ethernet port on each IP20C is connected to an optical splitter. Traffic must be routed to an optical gigabit Ethernet port on each IP20C unit. Both carriers of the slave unit are muted. See another view of the same MIMO configuration where we'll now highlight that, to build such a setup you must use 2 IP20C units on each side of the link, each on dual polarization, all 4 radio channels on the same frequency. 2 ONTs on each side of the link. IP20C can also work in a 2x2 MIMO configuration, as stated previously, case in which a dual-core mediation device must be used. Note that in 2x2 MIMO configuration both carriers work in the same polarization, of course, in the same frequency as well. In case you missed it, note that IP20C can work as an east-west configuration with each carrier pointing in its own direction, independent on the other. For such a configuration you again must use the dual-core mediation device, like shown in this slide. In this slide the AFR1+0 configuration is shown. Here the aggregator hub site has 2 independent links with 2 units in far end. Each radio carrier is connected to its own directional antenna. To build this setup you'll need a dual-core mediation device in the hub site and splitters in both tail site. Note also that in tail sites you can also use IP20S as an alternative to IP20C. A reminder now, for the 6 to 11 GHz frequency bands, channelization and diplexers are narrow. Thus a single IP20C unit might have to operate in 2 channels not covered by the same diplexer, meaning, in this scenario, that 2 different types of diplexer will be used. As an example, now looking to the graph, one diplexer may cover channel 1 and 2, while the other diplexer might cover channels 3 and 4. So, in this module we discussed about multi-core network needs and benefits, multi-core configurations, such as multi-core 2+0 single or dual polarization, multi-core 2+2 hot standby single polarization, 2 times multi-core 2+0 dual polarization, 1+1 hot standby with space diversity, 2+0 space diversity or 4x4 MIMO. Multi-core 2+2 hot standby dual polarization, 2 times multi-core 2+0 single polarization, 1+0 space diversity or 2x2 MIMO, east-west configuration, advanced frequency reuse and advanced space diversity. Thank you for your attention.
Okay, I'm coming. Stay now.